Okay, good morning class. So at this point we're looking at exponents and surds. We just sorted out that homework now. So we're looking at the example on page. Operations involving powers, multiplying and dividing powers. When multiplying or dividing powers, write the basis as powers of its prime numbers. Okay, we did this last year already. So the sum is just getting a bit larger now. So we're looking at the example on page 5. Example 1 on page 5. And this is for exercise 1.3, which is on page 8. Page 8. Okay. So of course the question says simplify or determine or calculate, whatever, or evaluate. Alright. So where do we start? We start by writing the basis in products of its prime factors. So let's look at 9. 9 can be written as what? So you press 9 equals shift factorize 3 squared. Not so. 27 can be written as what? 3 cubed. You press shift fact 3 cubed. Okay. Otherwise, even in an exam, you can't use a calculator and they ask you to write that as products of its prime factors. We divide it by prime numbers, the smallest prime number till it can't go anymore. And then we say 36 of course can be written as 3 squared times 2 squared. Okay. This is another way of doing it. Otherwise you can do the decomposition method as well. Okay, that's the ladder method. So we say that 9 of course can be written as 3 squared, the raised to the exponent, a plus 1. Okay, times 3 is already in its prime base, so it's going to be 3 to the 3a minus 4 over 27 can be written as what? 3 cubed raised to the exponent a plus 1 times 9 can be written as 3 squared raised to the exponent a minus 2. Okay, so what do I do now? The exponents here, the brackets, sorry, the multiplying exponents. That will simply be 3 to the 2a plus 2. Now many times learners write a 1 here. Watch out for that, okay? Remember that the 2 must be multiplied with the a and with the 1. Multiplied by 3. 3a minus 4 over what? 3 the 3a plus 3 times 3 to the 2a minus. So when we're multiplying and bases are the same, what do you do to the exponents? We add. Okay? If we divide, we subtract. What do you notice? That all these bases are the same. So it's 3. The exponent? 2a plus 2 times. No. We'll add the exponent now, of course. Because we're multiplying plus 3a minus 4. Now we're dividing here, not so. So it becomes minus 3a minus 3 because I'm minusing. So whatever the sign is here, if it's plus, you take it up, becomes minus. If it's minus, you take it up, it becomes plus. Okay, the sign changes. Minus 2a or the 3. Minus 3 is minus 2a plus 4. Okay. So that will be 3. What is 2a plus 3a? 5a minus 3a. 2a minus 2a? 0a. So that's gone. Cancels out. Okay. So what is 2 minus 4? Negative 2. Negative 2 minus 1. Negative 5. Negative 5 plus 4. Negative 1. So it's 3 to the negative 1. Okay, and 3 to the negative 1 is? 1 over 3. Is there any confusion? Yes, Michael?
So you need to sound like this, we don't multiply out the variables.
Yes, you write it as one basis. Okay, any other questions? Yes, Michael?
So why are we changing like 3a plus 3 and then we change it to 3a, negative 3a minus 3?
We're talking about this year.
Exponents. So when you carry
This year. Remember, what is the rule? When I'm multiplying and bases are the same, I add the exponent. So it's going to be 2a plus 2 plus 3a minus 4. But now when I divide, what do I do to the exponents? I subtract. So it's negative 3a plus 3 minus 2a minus 4. Remember, all of this is on that base of 3. No? So it now becomes 3, 2a plus 2 plus 3a minus 4 minus 3a minus 3. Can you see? Get rid of that bracket, minus 2a plus 4. And that is why the sign changes. Make sense? Anything else? You all understand? Alright. Go to the next example. This is example 2. Every example 2 is on page 6. And this is for exercise 1.3 on page 8. Alright. So where do we start? Factorize the basis, not so. Alright, so we know that 6 can be written as what? 2 times 3. Yes. 9 can be written as? 3 squared. 2 can be written as? 2. 2 remains 2 because that's already in its prime base. 27 can be written as? 3 cubed. Okay, as we did it in the previous sum as well. Okay. Okay. So it's going to be 2 times 3 raised to the a plus 1 times 9 we said can be written as 3 squared raised to the a minus 1 over 2a plus 1. 27 can be written as 3 cubed raised to the a. There's only raised to the exponent, we multiply the exponents. If there's no exponents, of course, there's a 1. You all agree with that?
Yes,
So this will be 2. What's 1 times a plus 1? A plus 1 times 3. A plus 1. What was me there? Times 3. So again, we're going to get rid of this brackets by multiplying the exponents. 2 times a is 2a minus 2. And this is all over 2a plus 1 times 3a. When we multiply and bases are the same, what do you do with the exponents? We add it. If we divide, we subtract it. Not so. So this will simply be 2 to the, remember now only these bases gets brought together. Because as you can see, only those bases are the same. Whilst those are the same again. Okay. So it will be 2 to the a plus 1 minus a minus 1. Don't make that mistake, no? Remember, the signs will change when I bring it up. Times what? 3, and all those exponents will again be brought together. 3 to the a plus 1 plus 2a minus 2
minus 3.
minus 3a. Okay? What do we have now? 2 a minus a 0. 1 minus 1 0 times 3 a minus 2 a plus 2a 3a 3a minus 3a 0. What's 1 minus 2? Negative 1. Okay. People, anything to the power 0 is 1. So this becomes 1, and 1 times anything is 1. Is the number, sorry. 3 to the minus 1? So it's actually 1 times 1 over 3, which is? Or you could have gone from this straight into that. Was there any confusion? No. So with that you should be able to do exercise 1.3. I want you guys to do number 1. There are 5 sums there. And 3a. And D. And H. We're going to say it again. Automatic your homework is exercise 1.3. Number 1 is 5 sums there. And number 3, A, D, and H. This deals with what we just did now. Okay? So we'll stop this lesson and I'll give you a chance now to start with the homework, and if there's any problems, we'll try and sort it out. Okay? And then on Monday we will do the second part of the exercise.